Okay, so let us get started. We're going to be trying to look at some patterns with numbers. The problems, as usual, look very simple. That's what I like about the problems like this. But then when we start playing with them, we find many interesting things. So, what are the natural numbers? What do we say are the natural numbers? Does anybody know? The set of natural numbers? What are the natural numbers? Okay, Judah. 1 through 10? Well, those are natural numbers. They are, but what about the set? All the natural numbers. Go ahead. 1 through 9? Well, 1 through 9 are also natural numbers. But what? Well, hold on. What do you mean 1 through 9? Well, those are the numerals of the decimal number system. How many different symbols do we use now that we're there? How many different symbols do we use to write numbers? 4 symbols? Well, we could use 4. We could use 4. We could use 4. So here, there. It's your choice. Whatever you want to say. Same here. So, all right. So, we could use 4. And we could use 4. We could use fewer symbols. But the point here is, yeah, we are. I'm going back a little. So, how many symbols do we use to write numbers? Let's just see if we understand that part first. How many different symbols do we use? 9. What are those 9 symbols? If you say there are 9, what are those symbols?
1, 2, 3, 4, 5.
You don't have any more symbols? You don't have any more? That's it?
0.
And 0. Let's put it right. So how many different symbols do we use? Do we have?
7.
We have 10. We have 10. Now, we're not going to do that now, but we could have more, or we could have fewer symbols. Okay? We could have more, we could have fewer. We're not going to do that now. That's a different exercise. But I want you to know, with these 10 symbols, with these 10 digits, these are called digits. Okay? Digits, or fingers. Okay? Digits. Okay? These are the digits because there's a connection between 10 fingers, 10 symbols. We can. Okay? Now, with 10 symbols, we create the numbers as we know. Well, we can see the natural numbers. So we have these 10 digits, and then how many numbers can we make with these 10 digits? How many numbers do we make? These are the digits. These are the symbols. These are the symbols that we use to represent numbers. Okay? Is that clear? We use some symbols to represent numbers. Like we use this number to represent what? It represents 5. It represents 5 things, 5 objects. Or just 5. Okay? So when I have 5, yes? Pizzas, if I have 5 pizzas, what I am doing when I say 5, I am establishing this is called a correspondence. I am establishing a correspondence between those 5 pizzas and the number 5. Okay? So, but now, the point here is, the point that I'm trying to make is, we have 10 symbols. We have 10 symbols. And with those 10 symbols, we create numbers. We represent numbers. And those numbers are, the natural numbers are these numbers. I'm not going to count 0 as a natural number. Usually, some mathematicians count it as a natural number, some don't. It doesn't really matter. It's just a matter of convention. Now, we are not going to, let's just consider the natural numbers to be 1, 2, 3, 4, 5, 6, and so on. Now, if I write, and I might do this, if I do like this, if I put 3 points there, 3 periods, What does it mean? Does anybody know what yes. It goes on and on. Yeah, but what goes on, you're right, but what goes on and on? Following this pattern, that's all it's going to mean. If I use, yeah, it goes on and on, but in a certain way. We've already established the pattern here. We've established, yes? Each period is a number? Well, you can think about it that way, but what we're saying is, when we use this, what we're saying is, this, whatever pattern you see here, goes on and on. Like if I write 2, 4, 6, 8, and then this, what does that mean? Exactly. That's what it means. I keep counting by 2. So I might use this notation when I talk to you today. So if I put this, what I'm saying is, the pattern that was established here goes on. Okay? The pattern that was established prior to this, seeing those 3 periods, it's the pattern that goes on. So so the natural numbers, to go back to that. The natural numbers are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on 11, 12, 13. What's the last one there? What will be the last one? Will there be the last one? Yes? 15. 15? Let's see, 15, will there be a last one? Maybe, what about 16? So, no? No what? There's no last, but they'll go on. Because if you give me a very big number, give me a big number. 1 trillion. Okay. So if I give you 1 trillion and 1, come on, and if I give you 1 trillion and 1, then what happens? I gave you a bigger one. So it's very easy. Anytime you give me a number, it doesn't matter how big it is. All I need to do is add 1 to it. That number is going to be bigger. Well, but those numbers are called natural numbers. There are other numbers that we're not going to talk about today. We've talked about them. Like if we have fractions, right? Those are other numbers. Okay? Some fractions are natural numbers. Some are not. Okay? But today we're only talking about natural numbers. So again, what are the natural numbers? The numbers that start at 1. We could include 0, sometimes we do. We're not going to include 0 today. So they start at 1, and then it goes 1, 2, 3, 4, 5, and they go on and on and on and on. That's it. Those are the natural numbers. Sometimes, yes?
Negative. Can we go on to negative?
Well, the negative numbers, those are called integers, okay? That's a big, I should not say it's a bigger set. It's just a different set that has other numbers, other members in that set, okay? Our set today only have positive numbers. They're called, some people in school, they call them whole numbers, counting numbers. We're calling them, the preferred way mathematicians call them natural numbers. We're calling them natural numbers, okay? So we know what natural numbers are. Now, the first question, I'm going back to our handout, it's very simple. It's very simple. What is the sum of the first 10 natural numbers? Numbers 1 through 10. Okay, Judah. 55. So, that seems fairly easy. I think, yeah, what is it? 45. Okay, so is it 45 or is it 55?
55.
Well, why don't we try it?
Look,
Yes.
I know.
You know.
Yeah, can I
Well, not yet. Hold on a second. Yes. Okay, so we're trying to add 1 through 10, right? 1 through 10. And several people said 55. I think someone said 45. Yes. And I just want to, let's see. Why don't we try again? And those of you who did, you can go to problem 2. What is the sum of numbers 1 through 20? I just want to see if we can start identifying some patterns. Okay? Numbers 1 through 10 first. And then if you're certain, then go for the second ones.
it all up.
Go for the second one.
Put the
And
same.
let's see if we can find.
19 plus 19 is 3, 10,
Well, how do you know that that's the
38.
case?
So
How do
then
you
you
know
have
that some of the other
38
two will be
plus
all 45?
38 plus
Leave that the next,
22
you're starting at 11
plus
now.
14 plus 6.
Oh, well, you need something different here.
That's
I'm just trying to see what kinds of patterns we can find.
12. 4, 7, 9.
I'm just trying to see if we can find some patterns.
Oh, I know it. Your battery's running low.
It is.
Can anybody share a nice pattern that you saw that maybe we can use, because I haven't seen any nice patterns yet for the second one. So maybe you need an eraser? I don't have an eraser here. But just use the back of the sheet. Let's see, what do we have here?
Mom,
Do you see a pattern, Judy? Help me see if you see a pattern. 1, 3, 6,
you have to
10.
multiply.
This is counting by fours. 3, 6, 10, 15,
No, I'm
21.
adding these two numbers so I can make it easier.
I know, but then the result is like, you see, this is like 3. That's counting by threes. 3, 6, 10, 15.
Oh, I messed it.
No, this is a pattern.
He never went over it. Oh, it's 45 or
I don't know.
55.
Let's see what he said.
Okay, let us first look at problem 1. I have people working on problem 1 and some working on problem 2 on each 5. So problem 1, we were adding 1 through 10. It was 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. I'm going to go on here. Plus 9 plus 10.
It didn't go up.
And we wanted to know what that sum was equal to, right?
Wow.
I know. Most of you said 55. Does everybody agree now that it is 55?
Yes.
How? How do we do it? Can somebody show us a nice pattern, a nice way to do this? I mean, of course, we can just say 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. We can do that.
I did.
But it's gonna, like, because if you look to the next problem, if you look at the next problems, then we're gonna go to 25 to 100. So, although counting the first 10, adding the first 10 natural numbers like that, it's fine. As we move along and we have more numbers, it's gonna get progressively more difficult, yes? So, let's see, what do you see there, Hope?
You can like add 1 plus 2 and 3 plus 4,
Yes?
and then all the way to 10.
Uh-huh.
And then you can do the 3 plus 7 from 1 plus 2, 3 plus 4. And
Like what? Let me see what you're trying to say. Do it on the board. And then, let's see, I'm not following you. Let's see. Is it too high for you? Yeah. So just read that. 1. Okay, what do you want to do? Let's see.
Plus 21, plus
so you
22,
can
plus 23, plus 24, plus 25,
Okay.
plus 43 equals 115. That's 9. Because 25.
Like that?
Because 25 is 1.
Okay. Okay, let's see what he's doing. So he's just taking them 2 at a time, and then he's combining. That works. Okay, we will see different ideas, and it's fine. It's fine. There is that. Okay. So again, that's great. Oh, so we had one way of doing it, which was 1 plus 2 is 3 plus 3 is 6 plus 4 is 10, and 5 15, and 6 21, and 7 28, and 8 36, and 9 45, and 10 55. We could do that. Or we're looking at different ways. So this way, what Holt did was he added them in pairs. This pair, this pair, this pair, this pair, this pair, and then 3 7, 11, 15, and 19, and then he added these two numbers. It's kind of a tree, right? So this is 10, and then he added this one with the sum of these two, and which was 36 plus 19 here, and that was 55. That's and any other way that you'd like to share with us? Again, we're looking for different ways to see maybe one is better than the other, or maybe more efficient. Let's see, what is that? Yeah, I want to show us something. Let's go. Let me write. We're trying to see if we can do. So the point is not only to find the answer, but see if we can find an answer that is more efficient. I like that
So
word.
to like
Let's
1
see.
to 5.
He added 9 and 1. Okay, let's see. That's 10. 2 and 8 is 10. Okay. Okay, I like that. So how are you? Do you see what he's doing? He's pairing up 9 and 1. He's making 10 groups of 10. He says 9 and 1. No, don't leave yet. Don't leave yet. We're not done. So he's pairing up 9 and 1, which is 10, 2 and 8, which is 10, 7 and 3 is 10, 4 and 6 is 10, and then, okay, how do we use that to help us figure out the...
Then I add the 10.
And then you add the 10 to what?
50, and then I add the 5.
Wait, but how do we know, how do we have 50? Tell me.
You start out with 40 or the 10.
Why do you have 40? That's not clear. Let's see if it's clear to everyone. Why do we have 40? There are 4 groups of 10, right? 1, 2, 3, 4 groups of 10, so that's 40, yes, and?
And add the 10.
Another 10, that's 50, and this 5?
55.
Good, that's another way. You see, we've seen 3 ways of doing the same problem. Okay? So now, are we convinced that it is 55? Okay, good. Let's move on to the second problem, 1 through 20. Let's see if we can use any of those techniques to help us at 1 through 20. Yes. Well, but this would suppose, this would assume that the number, the 11. I'm doing this now, but once we get to 100, I'm not gonna write them all. Put up. Wait. How do you, 55, wait, that 55 is coming from where? Where is that 55 coming from?
1 to 10.
The first 10, we already know that. The sum of the first 10 is 55. Wait, why are we adding 55 to that now? Let's see, hold on, give me yes. So, what she's doing is, she's saying that she already knows that the sum of these first 10 is 55. And now she's saying, what are you saying, Naomi, here? What do we have? Yeah.
Those numbers, if you take away
So
and then you add those two together, and then
which is very similar to what Holt told me. This 11 can be seen as 1 plus
10.
10. So she's saying this guy here, 11, this is just 1 plus 10, and this guy is
Judah, that's why I can do 10.
10 plus 2. 10 plus 3, 10 plus 4, 10 plus 5. So you say, wait a minute. So this is just I just have a whole bunch of 10s here.
Right.
This guy, this 11 is just 1 plus 10. And this guy is 1 plus, 2 plus 10. So she's saying, so I have now 1 plus 2 plus 3 plus 4 plus 5 plus 8 again. That's where she's getting this 55. I have, do you see this? 3 plus 10, 4 plus 10, 5 plus 10, 6 plus 10, 7 plus 10, 8 plus 10, 9 plus 10, and 10 plus 10. She's saying, I have again 1, 2, 3, 4, 1 through 10. That's this 55. And now what? And how many are there? There are 10 10s, and that's equal to? And you get 210. Great. Great. Can anybody share a different way of doing this? That's very good. Can anybody share a different way of doing this? There are other ways of doing it, and he hasn't shown me yet, so we'll see what he has in stock. So Felix wants to show us something. You know what? I'm going to keep going. They're not going to fit here. Again, we said we were going to do something. We were going to use those. 44? That's an 11. That's a 1. I'm going to write it here. Well, look, I'll write it here. Plus 16, plus 17, plus 18, plus 19. I hope that, okay, let's see another way. Okay, so he's saying up to here is 55. Good, okay. Now what? And 15 plus 20, yes?
35.
That's going to be what? What if I would have asked you first, what is the sum of the whole of the natural numbers 1 through 20? And you didn't know what the sum was from 1 through 10. Then what would have you done there? Now all of you are using the fact that you know what 1 plus 2 plus 3 plus 3, all the way to 10 is. You're all using that fact, but what if we didn't know? What if I asked you at first, what is the sum of 1 through 100? So now we see that we might want to find an even better strategy, an even better way of doing this, okay? 500, well, we can try, but I mean, what Felix is doing, Felix wants to take, again, it's similar to what Holt did before, which is fine. He wants to add these two and say this is 35, 33, 31, and then add those numbers, and that.
And then I have 2 numbers.
And that's a way of breaking it down, simplifying it, and yes, you will arrive at the same answer. That's fine. It'll be what? You don't need this. Right there. Now, so it is 300 plus 25, that's what? 325, very good. So that's the answer. Now, my question is, thank you, Drew. What about 100? That's right, Harper. Now, what about 100? Nothing that we've done so far, well, there are some elements in what we saw. On how we got to 20, how we got to 10. There were some things that some of you did that can help us. But right now, what are we going to do? We want to add now 1 through 100. And I'll tell you what. This problem, what's the sum of the numbers 1 through 100? This problem was given to a boy of age 6 called Carl Friedrich Gauss. One of the greatest mathematicians in history. Okay? Gauss was 6 years old, and the teacher, we're talking about what? The 18th century? Many years ago? So his teacher gave him a problem. He just wanted to keep them busy. He wanted to keep the boys, mostly boys, probably all of them boys. He wanted to keep them busy. Or actually, it was kind of a punishment. Okay? You know, sometimes some weird teachers say, right, I don't know, 100 times, I won't do this again or whatever. You know, some people do that. I don't do it, and many people don't do it, but some teachers do that. When you misbehave, they say, I don't know, I'm not going to do this again, and they make you write it 100 times. So it was some kind of punishment. Okay? It was some kind of punishment. He said, add the numbers 1 through 100. You know, the natural numbers 1 through 100. And Gauss was a 6-year-old boy. Carl Friedrich Gauss, he almost immediately, it took him a few minutes, he raised his hand, and he said the answer. And the teacher was surprised. Okay? He was very surprised. And Gauss, as an elder man, he would like to tell this story many times. He was very fond of telling this story of how he did this. And it's a very powerful counting technique that we use many times. So let's see, 1 through 100. Let's see if we can find what Gauss did. Okay? It's something that's very simple and very powerful at the same time. And the greatest mathematical ideas are like that. Simple and powerful. I'm going to do 1 through 10 again. See, the art of teaching mathematics is resides in knowing when to stop. You do not want to take away from a child the sense of discovery. Okay? It doesn't matter if it takes him or her a year to understand it. You don't want to take away the sense of, when you take that away from a child, when you take that opportunity to discover, you take a lot away. You really take a lot away. It doesn't matter whether we as adults understand it or not. It doesn't matter whether we as adults get frustrated with what our children can and cannot understand. It is not our role as teachers. I mean, we just have to be patient and let them explore. So, what can we do here with numbers 1 through 10? And we will use this technique then for 100. What can we do here? Anyone? Another way of doing this. Yes?
You can group the 10 and 1, the 2 and 9.
Okay, let's see that. If 1 plus 10 is equal to 11. And then?
9 plus 2 is 11.
9 plus 2 is also 11.
3 plus 8 is 11.
3 plus 8 is 11.
4 plus 7 is 11. 5 plus 6 is
4 plus 7 is 11, and 5 plus 6 is 11. So now I have 5 groups of 11, and 5 groups of 11 is 55. No. Let us see if we can use this with 25. Because see, 1 through 10 is even. Let me try 1 through 25 to see if this works. Let me see if I can use something similar to this with 25. Let's see, can I do something similar with 25, and then we'll do 100. Then we'll do 100. I'm going to go up to 25. To see if we can do something similar. Can we do something similar now? It's long, yes. Well, I can do that. I can definitely do that. I can add 1 through 25, and that'll give me what? Well,
You put 1 to 25 to 26 to
but what's going to happen in the middle? I can do that. I can take 1 and 25. I can do that. And 1 and 25 will be 26. And I can keep doing that. But how many terms, how many numbers do I have now? An odd number. So what's going to happen to the middle number?
One left over.
You add all the numbers first.
Yes?
And then for the middle number, you add it on.
What's going to be the middle number there? What's the number in the middle?
13.
13, right? 12 and 12 is 24. So this guy will be the one in the middle. So I can do that. And how many groups of 26 am I going to have? 12. That's right. So now it's getting more complicated than I wanted. I can do something else. See, this odd number here is throwing me off a little. It's throwing me off a little. Yes. What do we have? 1 plus
24.
Oh, okay. Okay, so you want to leave 25 out. I like that. I like that. That's exactly where I was going. So yes, this will work. I can do that. That's perfectly fine. But if I take this guy, because it's an odd number, I'm going to take this guy out, and now I have an even number of numbers. I have 24. So I'm going to leave 25 out. I like that. And then I'm going to add 1 and 24, which is
25.
very good. And then
2 and 23.
how many groups am I going to have now? Of 25. How many groups of 25?
11.
Wait a minute. 12 because we have 24 here.
Because when you were doing 25, you weren't including the 25. You got 12.
Exactly, because now we take this guy away, but look, this is very nice. 25 here and 25 here. So now I have how many groups of 25 here?
13.
How many groups?
13.
12 groups of 25.
The last one.
300.
Very good. 12 groups of 25, which is
Plus
300.
25.
It's like having 12 quarters.
And then you
Plus
add
25.
And then you have 25, and that's 325. Very good. Okay? Very good. Very good. So, with even and odd, we can play with it. Now, what about 100? We have 5 minutes. What about 100? Now, I'm not going to write all that. Give me a second, hold. I'm just going to write 1 plus 2 plus 3. Then I'm going to use these guys. Maybe I'm going to put right in the middle. I can just write 100. But I can write, just to make it more, what I'm going to do is, I'm going to write 49 plus 50 plus 51 plus 52 plus, and I'm going to write 98 plus 99 plus 100.
Wow.
Okay? What I did was, see, I truncated this sequence. I say, well, I'm not gonna write all those numbers. Now what? Now again, these 3 dots here stand for numbers 4, 5, 6, all the way to 49. Again, I could have stopped here, but I'm using those numbers to show the same technique. Then what? What do we have now? What do we have now? Can we use this technique, similar technique, 1 through 10 and 1 through 100? Now what? So what can we do now? Yes, Geffen.
You could do 1 plus 99.
You can do 1 plus 99, but then remember, yeah, you can do that. But then how many terms do we have? Is it even or odd? Even, right? And we have 100. So although we could do that, and that'd be great, if we go to, 100 sounds kind of nicer than 101. I agree. But you could do that. You could do that, or you could do what? Yeah, there are basically two ways of, well, there are more ways of doing this.
Is it okay if I use my color paper?
You sure? So now what do we have? Geffen, let's go. What do we have? If we go to 101, the first with the last one, we have 101. Then we have these two. What are these two?
101.
And how many groups of 101 are we going to have?
50.
50, right? Because we have 100, we have 50 groups of 101. But I want to take Geffen idea. So we have 50 groups of 101. And we can add that. 101 plus 101 is 202, and 303, and so on. We can add. We don't need to multiply. I mean, we can just add 101 50 times. And this will get us to 5,050.
Oh.
Or, yes, or,
You can just use the 1 plus 2 plus 3 plus 98 plus 99 plus 100. You don't need to use the ones in the middle.
oh, yeah, well, yeah. These, yeah, we don't need them here. But I was just wanted to show that this is also 101, and that this is also 101. But you are right. We don't need them. We could have just take, just 1 plus 2 plus 3, and then plus 98. You're very right. Plus 99 plus 100. Now, although we're almost out of time, I want to leave you with something else. Well, Geffen had said something. We could have made it to be 100, okay? We could have said, let's make it to up to 100, okay? And now, we could have thrown in a 0 in the front if we wanted, and say 100 plus 100 is 100, and then 99 plus 100. But then, now we have 101, we're going to have one guy in the middle, which is going to be 50. So we're going to have 50 groups of 100, which is how much? 5,050. So we could have taken your idea further, so it works also, and it's essentially the same idea. That's what Gauss came up with as a 6-year-old boy, one of the greatest mathematicians who ever lived. Next week, Miss Mary is going to be, I have to fly to Mississippi, but Miss Mary, who taught the class now, the 4th and 5th graders class next door, she's going to be here. And then on May 21st, last week will be our last regular session. And then on May 21st, we have the Julia Robinson Math Festival. And if you haven't registered, please do so. That's going to be great. We're going to have 20 different tables with 20 different activities going on simultaneously. Great geometric shapes that we're going to be building with pipes and things. So it's going to be awesome, all right? Yes. So, anyway, it's 10 o'clock, guys. Thank you for coming. I'll see you guys.